All right, welcome everyone to the third video here in our math review. Okay, so in this video we're going to be talking about calculus and some of the aspects of calculus we'll use in this class. Okay, so in this class we'll talk a lot about derivatives. Okay, in the second semester of physical chemistry we'll do a lot more with integrations. We'll have some integrations here, but mainly we'll be focusing on derivatives and using derivatives in this class. Okay, as a reminder, a derivative, right, is related to the slope of a line, okay, right? When you set that derivative equal to 0, that will find you a minimum or maximum of a function, right? Because at the minimum or at the maximum, the slope is 0, right? It's flat because it's turning over, okay? But again, derivative, right? Just slope of a line. It's the change of something with respect to change of something else, right? Right, derivative. Right, we can think of in general, right, like in kinetics and general chemistry, right, talked about like the change in concentration of something over change in time, right? Well, a derivative is just that change over a very small fraction of time, right? That, you know, in the limit, right, in the limit that delta goes to 0, right? That change goes to 0. This is looking at d of the concentration over dt, right? It's just that limit of that change getting very, very small, approaching 0. That's what a derivative is, right? Okay. So common derivatives that you're expected to know in this class, right, are things like taking the derivative of x to some power, right, or exponential of x, sines and cosines, logarithms, right? How to take derivatives take the derivatives of two things added together, two things multiplied together, things of that nature, right? So all of these different kind of general relations, right, you're expected to know how to do and be comfortable doing within this course. Okay. Now, in this class, we're going to be talking about partial derivatives, okay? The partial derivatives are going to use this like del symbol, right, instead of d something, d whatever, it's going to be del, right? My del symbols and d symbols look awfully similar, right? But in this class, don't worry about it, okay? Do not worry about when you see these partial derivatives and say, I have not taken that math, I've never seen partial derivatives before in my life, get out of here with that, right? Like, don't worry about it, okay? Do not worry about it, because all we're going to do in this class is, ever you see these del symbols, these partial derivatives, just think of it as a regular derivative. Because in this class, that's all we treat it as, okay? Okay, so in this class, let's say I have something where x and y are two variables, right? The partial derivative with respect to x in this equation here would just be equal to y. That's the same thing as taking the derivative of with respect to b times x, where b is constant, okay, and that would just give us b, okay? So, right, the point being is whenever you're doing partial derivatives, what you're doing is you're holding everything else constant and just focusing on taking the derivative of that one thing, okay? So in this class, that's how we're using partial derivatives. That's what we'll be doing with them in this class. And so basically, when you're taking the derivative with respect to x, and you have something that depends on a bunch of variables, right? You just pretend all those other variables are constant for the sake of taking that derivative, okay? Right, another example here is partial derivative with respect to x of something that depends on y and x, okay? You can kind of work through that example yourself if you like, right? Okay, so again, right, we'll see this notation here. Partial derivative with respect to y, or of y with respect to x, holding z constant. So this subscript here is saying z is being treated as constant. These are your constants, right? Right. This notation is used. Often we might be kind of lazy and forget to write the parentheses and put the z and things like that. Just assume everything else is being held constant, but the two things that are involved in this derivative, okay? But in this class, we'll take that even one step further, and we can just think of it as dy dx, okay? So you have something where it's like y equals x squared z plus x divided by z, or something like that, right? That's your function. Y is a function of x and z, right? If I want to know what is the derivative of y with respect to x, holding z constant, I'd write it as this, okay? But in this class, all we're going to think of it as is just what is dy dx, right? And just everything else is just a constant, right? And so what is dy dx in this example, right? Well, dy dx, right, is just going to be 2xz plus 1 over z. Okay? That's what dy dx is, right? And so again, right, we're not going to focus on like, whatever things, and maybe in the math class we get yelled at for doing this stuff, but we're not in math, right? And so we're just going to say, anytime we see these partial derivatives, just think of it as a regular derivative. Okay. So for example, right, we look at pressure as a function of temperature. Okay. We can ask what is dp dt and what is dp dv, right? What is the change in pressure with respect to temperature, and what is the change in pressure with respect to volume? Okay. And these might be partial derivatives, but I can think of this as just dp dt and dp dv, right? And often you'll hear me say dp dv and dp dt, and not del v and del p and blah, 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 blah. Okay, so if you take those derivatives, right, what you'll find is dp dt ends up just equaling n r divided by v, and dp dv is negative nRT divided by v squared. Okay, and I got these things by doing ddx of x and ddx of 1 over x, right? Just taking those simple derivatives, right? But in this case, right, x was equal to t, and in this case, x was equal to v, right? What I'm calling x, what I'm calling my variable, I'm taking the derivative with respect to, changes depending on equations, and that's fine. That doesn't matter, right? We can call things whatever we want. Okay. And lastly here is talking about integration, right? Integration mathematically is talking about like summing up the area underneath some curve, okay? The intervals that we expect you to know is the interval of like x to the n, exponential functions, 1 over x, and sines and cosines, okay? All right. And to kind of wrap up the math review here, just mention, right, so on exams, right, I will not expect you to be able to solve extremely complicated math. There will be some math you will have to use, have to solve. Typically, it will be mainly algebra. Sometimes there will be some calculus. Okay? Typically, the math will be harder on homework than it will be on exams, because on homework you have more time and you have access to the internet. Okay? And I got no problem with you using the internet to help solve your homework problems, especially when it comes to doing math. Okay? You know, and please ask questions throughout the semester about any math questions you might have with anything we're doing in the class. Okay, I have no problem answering those questions. I'm always happy to do so. And I'll admit, there are going to be times where I might skip some steps, some mathematical steps. Okay, that for me, because I've done this so much, right, might just seem intuitively obvious what happens next, how I got from A to B, okay, or let's say A to C while skipping over B, right? But it might not be obvious to you as to how I got from A to C, because you might not see step B because this is your first time seeing this stuff, right? And so I do apologize if I do that ahead of time, right? But please ask me, how did I get from A to C, right? What happened there? And I will be happy to explain it, okay? All right, well, hopefully this math review has helped ease your concerns about the math involved in this course instead of growing those concerns. Yeah, next lecture videos will start on actual physical chemistry topics.